Welcome to The Explainer. Today we're diving into a question that's honestly a real mind-bender. We're asking, what is math? Is it something we discover out there in the universe, like a new planet? Or is it something we actually invent, a game we create using nothing but pure logic? This isn't a new question, but it's one that has kept the greatest thinkers up at night for more than a century.
And look, this isn't just some dusty philosophical debate. The answer really matters. It gets to the heart of whether numbers are part of the very fabric of the universe, or if they're just part of the architecture of our own minds. And that kind of changes how we think about reality itself.
So here's how we're going to tackle this. We're going to follow the incredible, dramatic story of this idea called logicism. We'll start with its really ambitious beginnings, watch it all come crashing down in a stunning failure, and then see how it made a surprise comeback that, you guessed it, created a whole new set of puzzles for us to solve.
All right, first up, what if math is just logic? That's the big idea behind this whole philosophical movement called logicism. And its goal was nothing less than to completely rewrite our understanding of what numbers even are.
So what does that actually mean? Well, the core idea is that a truth like 2 + 2 = 4 isn't a fact about the world we observe. And it's not something we grasp with some kind of special math intuition. No, the logicists said it's just a very, very complex logical truth, kind of dressed up in the language of arithmetic.
And the main champion of this grand project, the guy who basically dedicated his life to proving it, was a brilliant German philosopher and mathematician named Gottlob Frege. Frege's goal was all about certainty. He wanted to prove, once and for all, that we don't need to look at the world. We don't need to rely on some fuzzy idea of intuition to get math. He believed we could build the entire system of numbers from the ground up, using only the bare-bones rules of logic itself.
So, he poured all of this into his monumental life's work, a book called the Grundgesetze der Arithmetik. This was it. This was supposed to be his magnum opus, the final, undeniable proof. He thought he had built this perfect, indestructible cathedral of reason.
But this is where the story takes a wild turn. Just as Frege was about to publish his final volume, just when he thought he'd done it, his entire cathedral came crashing down, and all because of a single, devastating paradox found by a young philosopher.
The timing is just brutal. You have to feel for the guy. It's 1902. The second volume of his life's work is literally at the printers. And then he gets a letter from a young Bertrand Russell. That letter pointed out a paradox that just shattered the very foundation of his entire system. And with what you have to call incredible intellectual honesty, Frege actually added a note to his own masterpiece, basically admitting it had a fatal flaw.
You can just feel the devastation in Frege's reply to Russell. The problem, which we now call Russell's paradox, wasn't some tiny error. It was like a self-destruct button hidden deep inside one of Frege's most basic rules. Frege was worried it didn't just break his system, he feared it broke any attempt to build math from logic. So what was this paradox? Well, the easiest way to get it is through the famous barber analogy. Imagine a town with a barber who shaves all the men in town and only the men who don't shave themselves. Simple rule, right? But then you ask the killer question, who shaves the barber? If he shaves himself, well, he can't, because he only shaves men who don't shave themselves. But if he doesn't shave himself, then he must be shaved by the barber, which is himself. It's an impossible, inescapable loop. And that is the exact same logical knot that Russell found at the very heart of Frege's system of sets. It just blew a hole right through the project.
So for decades, it seemed like that was it. Logicism was a noble effort, a brilliant failure. But then, philosophers found a kind of loophole. A different, more stable principle that Frege himself had actually talked about. And this led to a pretty stunning revival, which we now call neo-Logicism, or neo-Fregeanism.
So instead of using Frege's flawed rule, modern thinkers like Crispin Wright and Bob Hale went back to this other idea, which they named Hume's principle. Now, it looks simple, but its power is in what it lets you do. It gives you a way to know that two groups have the same number without ever having to define what a number actually is first.
The idea behind it is actually super intuitive. Imagine you're at a dinner party. You see a rack of hats in a room full of guests. If you can match every single hat to exactly one head, with no hats or heads left over, you know for a fact that the number of hats is the same as the number of guests. You don't have to count them. You just have to match them up. That's one-to-one correlation.
And here's the absolute aha moment. It turns out that this one single principle, now called Frege's theorem, is powerful enough all by itself to derive all the basic laws of arithmetic. Addition, subtraction, you name it. It all flows logically from this one idea. The core of Frege's grand project, it turned out,
could be saved from the ashes, after all.
But of course, it's never that simple. This comeback story wasn't a happily ever after moment, because saving the project with Hume's principle ended up creating a whole host of brand new, really tricky philosophical problems.
Which brings us to my favorite bizarre-sounding problem in philosophy, the Julius Caesar problem. It sounds like a joke, but it's dead serious. If we define numbers using Hume's principle, how do we know that the number of Jupiter's moons isn't the exact same thing as the person Julius Caesar? The principle is great at telling us when two numbers are equal, but it doesn't give us a way to tell if a number is different from, well, a Roman emperor.
And the tough questions just kept coming. First, you've got the bad company objection. Basically, philosophers ask, hey, the last principle you used looked a lot like this one, and it led to total disaster. How do we know this new one isn't just keeping bad company? Then there's the problem of epistemic innocence. Can we really just say Hume's principle is true by definition, or is it secretly smuggling in a giant assumption that an infinite number of things, the numbers themselves, actually exist, which is something you'd probably need to prove?
These questions basically split the whole modern movement into different camps. You've got the Scottish school, with guys like Wright and Hale, who are mostly focused on the knowledge problem. How can logic explain how we know math with such certainty? And then you've got another group, the Stanford/Edmonton school, who are more focused on the reality problem. What kind of abstract things are numbers anyway?
And that brings us right back to where we started. The incredible story of logicism. From its huge ambition to its spectacular collapse and its ingenious revival, it really shows us that the search for certainty, even in a field as pure as math, is a dramatic, messy, and deeply human adventure. So is math that perfect cathedral on a foundation of solid logic, or is everyone still searching, trying to find solid ground?